SPADEX Mission Overview. The PSLV C-60 SPADEX mission is scheduled to launch on December 30, 2024 from Satish Dhawan Space Center in Sriharikota. The mission aims to demonstrate advanced space docking technology, which is pivotal for the success of future lunar exploration missions and establishment of India's own Bharatiya Antariksh Station, Indian Space Station (BAS). Such missions represent a cornerstone in India's ambition to become a leader in space exploration. The Space Docking Experiment is an economical technology demonstration mission developed by ISRO. Its objective is to showcase the docking of two small spacecraft in orbit, a task requiring precision, advanced navigation, and robust autonomous systems. Docking technology has been the backbone of modern space exploration missions undertaken by agencies like NASA, Roscosmos, and CNSA, China's National Space Administration. The mission will use the Polar Satellite Launch Vehicle (PSLV C-60), known for its reliability to place two spacecraft Chaser SDX-101 and Target SDX-02 into low Earth orbit at an altitude of 470 km. PSLV has been a workhorse for ISRO, demonstrating consistent performance with over 50 successful launches. Space docking, an essential capability. The docking process involves connecting two spacecraft with exceptional precision. This process enables critical operations such as refueling in orbit, cost-effective alternative to launching additional fuel from Earth, repairs and maintenance, extending the lifespan of satellites and space stations, crew transfer, ensuring safety and efficiency missions during requiring human presence. Globally, space docking technology has facilitated advancements like assembly and operation of International Space Station, a multi-level national project involving NASA, Roscosmos, ESA, JAXA, and CSA. This capability is also crucial for future Mars missions and lunar bases. Docking versus berthing. Docking in this approach, spacecraft autonomously navigates and connects to space station. The automated systems use onboard sensors and advanced algorithms to achieve precise alignment. For instance, the SpaceX Dragon spacecraft employs this method to dock with the ISS. Berthing. This involves a robotic arm on the space station capturing the spacecraft as seen in Northrop Grumman's Cygnus resupply missions to the ISS. Berthing requires manual intervention from the Earth-based control centers. Objectives of SPADEX. SPADEX aims to develop and demonstrate autonomous docking capabilities, a technological milestone that only US, Russia, and China has achieved. Autonomous docking. Achieving precise docking of the Chaser and Target satellites at an altitude of around 700 km. This requires advanced navigation, coordination, and propulsion systems. Space handshake. Both satellites, traveling at a speed of 28,000 km per hour, will align with sub-millimeter accuracy to form a unified structure akin to a space handshake. Such capabilities are vital for assembling modular space stations, on-orbit satellite servicing, and long-term exploration missions. Autonomous rendezvous and docking. The spacecraft will automatically navigate, approach, and dock with each other without manual intervention. This involves technologies like LIDAR, radar, optical sensors for real-time measurements and decision-making. NASA's Orion spacecraft and Roscosmos Progress vehicles have successfully demonstrated similar capabilities. Maintaining a relative position between spacecraft with high precision is essential for future applications, such as in-orbit assembly. Formation flying is also used in multi-satellite missions like ESA's Earth Observation Program Copernicus and NASA's Gravity Recovery and Climate Experiment GRACE. One spacecraft will control the altitude and orientation of the other. This feature is critical for future autonomous missions where human intervention is limited due to communication delays such as deep sea explorations. Use of robotic arm. Testing robotic arm technologies integration to space manipulation and servicing. Robotic arms like Canadarm and Canadarm2 have been instrumental in ISS assembly and maintenance. Space exploration, developing indigenous, cost-effective, and scalable docking technology, positions India as a major player in global space exploration. The mission underscores ISRO's capability to innovate and deliver high-value solutions. SPADEX lays down groundwork for Gaganyaan, India's human spaceflight program requiring reliable docking for crew transfer. Chandrayaan 4, a potential mission to retrieve lunar samples. Indian Space Station (BAS), permanent infrastructure in space similar to the ISS. Private sector participation. SpaceX marks a milestone in involving private companies in space missions. Under the IN Space framework, private entities are now contributing to satellite integration, a first for ISRO. Future impact. The mission fosters opportunities for international collaborations in space research, building a sustainable space economy, earning foreign exchange through satellite servicing and technology sharing. Other potential applications: extending satellite lifespans. Docking can enable refueling and repairs of geostationary satellites, saving cost on new launches. Interplanetary missions. Docking technology will play a pivotal role in multi-stage missions to Mars and beyond. Solar power stations in space, facilitating the construction of massive solar arrays to harness clean energy of Earth for Earth. Challenges of SpaceX: complex docking systems. Satellites traveling at 8 to 10 km per second require precise alignment and synchronization. Advanced communication protocols are essential to avoid errors. Navigation and control systems. Failure in navigation or propulsion systems can lead to catastrophic collisions. Similar challenges were encountered during early Apollo docking missions. Autonomous systems, executing real-time autonomous operations involving managing multiple variables such as relative velocity and trajectory. This demands sophisticated AI and robust fail-safes. Sensor reliability. Space docking relies on high precision sensors like lidar, cameras, and radar. These instruments must withstand harsh conditions, including radiation and micrometeoroid impacts. Space debris. High-speed debris poses significant risk to spacecraft. Microgravity effects. Instruments and systems must adapt to unique microgravity conditions. Communication stability. Ensuring uninterrupted data transfer between spacecraft and ground stations is vital. SpaceX mission represents a transformative step for India's space program, propelling the nation into the ranks of global leaders in space exploration and technology.